Hi everyone. I just wanted to make a really quick recording onto how you could predict a variable if you had a data set that was the relationship between that variable and say body mass. So I've quickly found a data set for brain size to body size among mammals, and I want to predict the brain size in my mythical creature. So I'm going to show you two ways to do this, one in Excel and one in R, and I'm going to upload the code for you to help along the way. So we'll do Excel first. So there's a few little hints and tricks to working through Excel. First thing we might want to do is plot our data. So I can highlight a couple of columns, Control, Shift, down, and it's going to highlight all my data for me. I'm going to navigate back to the top. So when I go Insert, Scatter Plot, I can see a plot of my data here. Now you notice all my data is bundled in that little corner. That's because it's not log transformed. So I want to log transform it. I'm going to go log 10 equals log 10, and I'm going to click on that first one for body size, and I can drag it across, and you can see it also drags across that formula. Highlight both columns, double click on this little square here, and it'll just drag it down all the way. Okay, so we're looking good now. I've just clicked on one of my data points and you notice it's brought up a purple box and a blue box. So this is what's being plotted in this chart. The purple box is the X, the blue box is what's on the Y. I can actually drag these across, and I'm going to drag that X across and drag the Y across. And you notice we have a straight line. I can't drag it from that little square. I have to drag it from this blue line. Those little squares will allow you to resize the box, but won't let you move it along. So I want to move it along, and so now our plot is looking good. Um, and I want to know what the relationship between these variables are, so I'm quickly going to click on my data, right click on my data, add trend line, and then check the boxes for show equation and R squared on the chart. So there we have R squared and our equation, and I can write down these numbers, 0.75, so that's close to the scaling that we might have seen for metabolic rate, which is really quite interesting because it answers one of the questions I actually got asked in the lecture, is could this scaling for metabolic rate actually be related to brain size? Well, certainly could be, at least for this mammal data set. Okay, so that's the slope of the line on a log-log plot. So now I might have some unknown data. So this might be for my mythical creature. And say my mythical creature is 100 kilograms. So I'll call this unknown kilograms. And I want to know what its brain size is. Well, remember this is a log-log plot, so I also have to log transform my data. And you can see it comes out to 2. So it's going to be somewhere around here. So I expect an answer somewhere between 2 and 3 based on this chart. But we can do better than that. I can now use this formula. So it's going to be equals, this is going to be the X. So I'm going to do 0.7517 times, which is the little star, what is going to be on my X, which in this case is 2, plus the intercept, and I get 2.4, which is about right for where we expect my mythical creature's brain size to be. But that's, remember, in log transform data. So to unlog transform it, I'm going to go 10 to the power of that number, and that now unlog transforms my data. You can see it's about 270 cubic centimeters is the estimate for brain size in my mythical creature. Okay, we can also do this in R. So in R, you don't have to run these lines unless you want to. So mass actually has a data set like what we saw with the Annull data set in lab 1. So you can run that install packages once if you like, and run this library. And if you do, you can upload, you can just call the data set in from mass, but you might have a different data set, so you might have to do something like read.csv, I'll make it like that, arrow, read.csv, and then point it to where your data set is going to be. So this would be your data.csv, and you could call that in there. I'm not going to do that in this case. We've got plenty of examples of reading CSVs from the lab data. I'm just going to use this data here. So now we can plot it again, and you notice that again it's not very well distributed when it's unlogged. If I plot the log xy, so this is just a function that's going to plot them on a log axis, you can see that now it looks much nicer. Okay, so now I can create, you can see I've just got brain and body size. I want to log transform them, which is what I'm doing here. Create a linear model. There's my slope again, and I can put a line through the plot. And now I have my mythical creature. That's its mass. I'm going to make a mythical mass variable. And this is the tricky part. In order to predict it, I have to put it into a data frame, and you call up this log mass here. So that's going to now equal what my log mythical mass creature is. And so I have a little new data frame with one observation. And now I can run this predict function here using the fit that we created here. And you see I have an estimate now of my brain volume. I have to unlog transform it to get the actual number out, and we get the same number there, 269 cubic centimeters. So that's quite cool. We could do an extra little step, which is where we we get it to estimate the intervals, the confidence intervals, and if we do that, then we get the estimate for the brain size as well as an upper and lower estimate. So that's what the LWR, that's lower and that's upper, and you could just log transform these, and this would give you the fit and the lower and the upper estimates for brain size for your mythical creature as well. But this might be metabolic rate, it might be, you know, area that this creature needs to survive or something, or how much body mass, how long its limbs would be or something like that. So you can make some fun little predictions using that estimate there.